We are live. Hello, everyone, and welcome to HackerRank TV. Today is the day of many firsts. This is my first time hosting a HackerRank TV live stream, so fingers crossed it goes well. This is the first time we're hosting a LinkedIn live stream with an all-star, so welcome, Emily, and congratulations. This is the first time we're hosting a live tutorial, so I'm super excited to get started today. Today we're streaming across LinkedIn, YouTube, Twitch, Twitter. So wherever you're tuning in from, you can just drop in your comments, and I can conveniently see it on my side. So I'll just go ahead and put them up whenever. So yeah, feel free to drop in your comments. Feel free to welcome Emily, and yeah, I mean I'll just get started with the introduction. So welcome Emily. Our guest for today, All-Star Emily Brantner, spent 7 years immersed in the fascinating academic world of biology. Seemingly all of a sudden, Emily leapfrogged to the wonderful world of data science. Today, Emily juggles being a student of data science at UC Berkeley, a full-time analyst at Bird, and most recently, a HackerRank All Star. As a data scientist, Emily naturally has a significant amount of experience with Python. And today we're diving deep into one library she's particularly fond of, Pygame. Emily, welcome to the live stream. We can't wait to share your exciting journey with the world and take our first steps in Python game development today.
Yeah, thanks for having me here. Really excited to have a conversation and show how Pygame works.
Awesome. So I see that we already have a couple of comments coming in. So Dheeraj, welcome. He's tuning in from Rajasthan in India. Mahesh, welcome. He's tuning in from Nepal. Aditya is just tuning in from India. So welcome you guys. And we see that Kyle is excited about learning Python today. Welcome, Florjan. I'm sorry if I'm not pronouncing your names right, but welcome to the live stream. Please feel free to keep commenting and I'll keep featuring them on. So, yeah, let's get started with the live stream. Emily, I have a couple of questions for you today. So, we'll just get started with that before we jump into the tutorial. Emily, your professional and academic life so far could literally be a Hollywood movie. If you had to give our viewers today a 1 minute trailer of it, how would you do it?
Yeah, if I just had to kind of do this in 1 minute, I'd basically say I started off studying frogs. I've got a frog on my wrist. I don't know if you can see it. It's kind of upside down. And from there, I did that in undergrad. Got to go to lots of cool places. After undergrad, I lived in Panama for 6 months, where I was working on an orchid farm and studying frogs, which was pretty cool. And then I went to grad school, where I planned to continue studying frogs. I loved teaching. I really wanted to be able to be a professor, but I realized that in order to be a professor, I also had to have amazing research. I just didn't really like the research. I didn't like collecting the data more than anything. It was cool to visit other countries and collect frogs, but I was by myself and I liked talking way too much for that. So I ended up, hey, there's somebody from Panama right there. I ended up finishing up with my master's instead of a PhD, which is what I was in the program for. And when I finished that, I went and got a job for the Environmental Protection Agency. So I was a contractor there. And on the side, I started teaching myself SQL. I kind of saw, data science is big. And in all honesty, it seems like a really big pivot to go from biology to data science, but it's all statistics, right? I had learned a ton of statistics in my biology program. That was most of the classes that I was taking. So I started learning a little bit more of the coding side. And yeah, taught myself SQL, used that in order to leverage a job at SAP as an analytics and insights consultant. And from there, I enrolled in the data science program at UC Berkeley and have been continuing to learn that ever since. Was able to take that experience and translate it into an analyst position at Bird. So that's how I got where I am.
That's honestly fascinating. I mean, I think a lot of people get started on their data science journey with SQL as you did. So I think a lot of our viewers today can relate to that. So, I mean, yeah, awesome journey so far. Another question I have from you, just leapfrogging from that. So,
Yeah.
how did you go from having a bachelor's and master's in biology to becoming a data analyst? And I know you gave us some light on that, like how you said biology, it's all like stats and data
Yeah.
basically. But
Yeah.
if you could just, expand on that particular journey, it would be great.
Yeah, so whenever I worked for SAP, I joked that I went from doing data analysis on frogs to doing data analysis on businesses, right? And now, even more kind of uncanny, the lab that I was in whenever I was working on my master's, it was an urban ornithology lab. So ornithology is the study of birds, urban is cities, right? And now I work for birds in cities, except they're scooters in cities. So I don't know. I think that's kind of funny. But yeah, it's like I said, it's not a huge pivot. It's I feel like a little bit of a sellout sometimes because I went from the job where I wasn't going to make a whole lot of money to one where I do okay. um, and yeah, I like I said, I wanted to be able to teach. I realized that I would have to have stellar research for that, and I just didn't enjoy the research. So as soon as I finished with the masters, I was looking for some sort of pivot. I went down a couple of roads. I was like, maybe I'll switch and I'll do a PhD in nutrition. The science in that wasn't hard enough for me, I'll say, because it was a lot of qualitative research, which is great, super important. Doesn't interest me as much. So kind of continued that search. It's like, hey, I have to get a job in the meantime. So I went to work for the EPA. Obviously, I think the environment's important, so that seemed like a good step forward. Really cool. I worked for the scientific integrity program, so they were trying to like keep politics out of science, which is a really important thing, kind of a really cool area to work in. That actually weirdly gave me a bunch of experience in graphic design because that's sort of what I picked up. I started working on a lot of our like flyers and everything that we sent out, which it honestly goes really well hand in hand with data analysis because as we create dashboards and all sorts of things like that, I have a little bit of a leg up sometimes in that area because I have a pretty strong background in design now. So I can kind of take what one person might just kind of put numbers on a screen and actually make it look pretty and a little bit more human readable. So all of these skills have kind of built on top of each other, the statistics, the graphic design, all those pieces. And then the parts that I started building for myself, like, hey, I'm going to learn SQL. Hey, I'm going to learn Python. I actually learned a little bit of R in grad school and started learning, or I just decided to try Python out and realized, holy cow, I like Python way more than R. I mean, R has some really, really great things in it. Don't get me wrong; it is fantastic for visualizations, but at least for my brain, Python just feels a little bit easier. I don't know if I
Makes
fully
sense.
answered the question there, but that's kind of been that's been the direction, and everything just gets a little bit more coding heavy with every step that I take, which has been fun.
Yeah, no, that makes sense. I mean, I think a lot of people get started with languages other than Python. For example, I got started with C++ plus plus in college. And then when I started coding in Python, I was like, oh my God, there's a lot of things that's just like condensed into libraries in Python. Why haven't I been doing this like for the past few years? So yeah, I think Python is like a language that a lot of people are fascinated by when they get started.
And actually, you talking about C++, that's part of the reason why I enrolled in the data science program. Because most of my background is in biology. As I was working at SAP, most of my like cohort had computer science degrees and all of those pieces. And so while I learned the SAP stuff pretty well, I didn't have some of the same background that they did. So as I was
Mhm.
trying to move into the tech world, I decided I really needed a degree that kind of put me into the tech world and let me understand what was going on under the hood.
Makes sense. I think with that, my eyes flashed across this interesting comment that we got from Kirti Pandya. Thank you for tuning in today, Kirti. So he asked, what do you think about Julia? Will it replace Python in the future? And I see that this is like a popular topic of debate in developer communities today. So yeah, would you like to shine some light on this, Evan?
Sure. I don't have any strong opinion here. I have not learned Julia, but I have certainly kind of seen it rising up through the ranks. At least the little bit that I've seen, it almost feels like it's following a similar path to Python. I when I was a kid, I don't know, I was probably 11 years old, and I started teaching myself HTML because I played the game Neopets, and there were guilds in Neopets where you had to like you could actually use HTML and make the like little homepage of your guild. And so I started learning HTML because of that. And my dad somehow came across like a Python book. So when I was like 11 years old, I had a book on coding in Python. Never read it, like never touched it or anything, but I think that was around the time that Python was starting to pick up, but it was still sort of on the fringes. And like I said, I don't know that much about Julia. I haven't looked into it a whole lot, but I almost see it sort of following a similar path of like, hey, here's this new thing, and then more and more people start picking it up. So could it replace Python in the future? Sure, it could, but I don't know. Don't have great insight there, but
Yeah, no, I mean, you did give great insight because I think the world of tech and programming languages in specific, it's so unpredictable. Like, who would have thought like 5 years ago that Golang would be like one of the most popularly used languages in companies' tech stacks today? So yeah, I
yeah.
mean, it's we never know. Julia may replace Python, but for now, I feel like Python is definitely the king of programming languages. So
But basically, we all have to retool ourselves every 5 years anyway.
yeah,
Something new will come.
yeah. Oh, cool. I think, yeah, we have another comment, another insight from Bruno. He
Yeah,
says it's kind of like answering the eternal question, what is the best language? The best language is that which makes more sense to your brain. And, yeah.
absolutely. I mean, in the world of data science, right? Because I'm not a computer programmer per se, right? I'm more on the data side of things. The argument is between Python and R typically. So, which I brought up a little bit earlier. I like R way more. There are a lot, or I'm sorry, I like Python way more. There are a lot of data science scientists out there who never want to step away from R. I mean, the world of academia is totally tied up in R. Like everybody who was doing anything in biology, it's all in R. So
Makes sense. Cool. I think, yeah, that was a great discussion, Emily. I'll just jump into the next question I have for you, which is what do you like about your current job at a fast growing company like Bird? And is there any learning from your stint in biology that has been very useful in your work today?
I really, really like my job. I really like the culture at Bird. And I'll shout out to SAP as well. I really liked working there too. I feel like I've been extremely lucky with the companies that I've worked for, where both of them care about the individual. Like I never really felt like a number. I always had people there to support me and help me grow and help me get where I want to be. And I have the same thing right now at Bird. It's really, really great, and it's cool to kind of be sort of in the beginning. I mean, we just went public. It was really cool to be here and be a part of that, and actually go through it. And I think we have a great product. I come from the biology, the environmental world. Anytime we can get cars off the road and reduce the amount of carbon emissions in the air, I think that's fantastic. So now I get to work on something that I'm passionate about, and that may have been the piece that I was missing at SAP. Loved the company, loved the people, but I mean, sure, SAP has great things. It's awesome, but it wasn't something I was passionate about, and now I can actually feel this passion towards what I'm doing. So that's been really, really cool. And I guess that kind of answers the question of how the biology plays into it. Um, I'm not doing anything like strictly biological, and I was an ecologist, so it's not like I would be one of the people saying, okay, well, if a person stands on a scooter, this angle would be like this, because I wasn't like a medical biologist, right? So I guess it's really just sort of the environmental piece of it, and the fact that it ties in with my interest that way, and I get to use the statistics that I learned. But other than that, there's not a strict kind of one-to-one like, oh yes, the biology is played out here. The statistics I learned while doing biology helps me out here, and my love for all things ecology makes me really excited about what we're doing.
Makes sense. I mean, congratulations on Bird going public. I wasn't aware of that, but that's like big news. And it's great that you're getting to work on something you're passionate about. I think that's something a lot of, especially like young people in the workforce, they really want to pursue that, but they find that they can't break into that, especially working on something that they're passionate about. So yeah, I mean, that's awesome hearing that you've broken into that. So yeah, I see that we have a couple of other questions. So we have Marina who asks, what was the best way for you to learn programming? Is it YouTube tutorials? Is it coding camps? So, I'm sure it's a mix of everything, but Emily, yeah, if you would like to take this.
Well, first of all, shout out, hi Marina, because she's also a bird person. But for me, so I was saying, this is a HackerRank thing, so I got to give a shout out to HackerRank. HackerRank is fantastic for practicing for coding. Anytime I had an interview that I was going to use, usually for me it was SQL, was the main thing for the interviews. It was HackerRank that I'd log on to and just end up kind of pulling up a bunch of SQL practice problems and going through. Super, super helpful because I wasn't using SQL every day in my job. Even when I worked for SAP, I had to learn SQL to get the job. Like they tested my SQL skills, and then I never wrote SQL the whole time I was there because it has more of a drag and drop interface. So it wasn't something that I had to do. So when I applied for Bird, even though I had learned and knew SQL, I definitely needed to kind of brush up to brush up on my knowledge. So HackerRank, awesome for that. As far as actually learning it, for SQL, the very first thing I did, I logged onto edX and I took a couple of their free classes. You can pay for certification, but I just did them for free. I think I actually started with the Microsoft Database Administrator program or something and went through that, taught me SQL, and it taught me about databases because I lacked that knowledge. I was trying to kind of skill myself up. Then I moved on to Code Academy, is one of the things that I used for actual tutorials. That one was pretty helpful. Ultimately, the one that I landed on, because I'm in the data science world and the data world, was Data Camp. They have a lot of tutorials on how to write in Python, SQL, R. And so for me, that one was really great for learning. It's usually the one that if people are interested in programming from a data perspective, I usually send them towards.
That makes sense. I mean, that was very insightful, Emily, because again, it's like, as I said, a mix of places.
Yeah.
It's Code Academy, it's edX, it's HackerRank, it's Data Camp for those who are particularly interested in upskilling in data science. So yeah, thank you for answering that.
Similar to the comment about, it's all about which one you like the most. It's the same, right? I mean, of the things that I've said, Data Camp actually costs money, so it's kind of nicer to do some of the free ones too. But I probably, because it costs money, it allows them to kind of lay it out in a nicer way. But at some point, try a bunch of different programs and see which one you like.
That's great advice. I think every developer needs to follow that, especially the ones who are just starting out in their journey. So yeah, I see that we have a couple of comments who are already asking about when we're going to start the tutorial. So I think let's get started on that.
Sure.
So yeah, let's just first of all give an intro to what Emily is going to be teaching us today. So Emily, could you start off by telling us a little more about this game project of yours, Swooter, that we will see today, and how this idea came about, where you're going to use it, and how much time it took for you to build it, and then we can jump into the tutorial.
Yeah, so the game is called Swooter. It's sword shooter, and honestly, it was just a random little idea in my head. I was taking a data engineering class, and we needed to set up our own data pipeline. And the idea was like, oh, it's a game, and there are a couple different. You could have as many different data points as you wanted, but there were just a couple things that they wanted. Okay, it's gonna start here and end over here, and I decided it would be fun to go above and beyond and actually create a game and make it so that whenever you played the game, it would like send your information over, all of those fun things. I'll be honest, I didn't get that part to work. So I built a game and then I built a data pipeline and I did not weave them together. I would have had to use, I think, Flask and all sorts of fun stuff to actually host it online. It was the hosting online part that, since I had limited time because it was a homework project, I ended up just kind of submitting them separately and then just making the data pipeline the way that the homework was initially supposed to be done. But I definitely spent more time probably on the game than I did on the data pipeline. I don't know. It didn't take me that long, maybe 20, 25 hours. And honestly, it was just because I didn't know the package. We're going to create a small game here in like 45 minutes or less, right? So once you actually know it, it doesn't take that long and kind of understand it. Then it becomes a pretty simple thing. I think my whole code was I don't know, around 350 or something code lines, and the one for this is like 150, and that includes a bunch of blank spaces too. So, so yeah, the package is pretty cool. And actually, I guess they just recently released Pygame 2 as well. So putting it out there, this is not my package. This is just one that I found that can make games, and it's pretty fun.
Awesome. I mean, I think, yeah, I got another conflicting comment, which was, no, I like these insights on how to start. Don't start a tutorial. So I'm not sure what the audience wants, but I think it's a great time to get started on the tutorial. And yeah, don't worry, we'll take all of your other career questions or data science related questions right after the tutorial or even in between. So keep dropping it in the comments. And yeah, Emily will keep answering them. And yeah, I think we can get started with that, Emily. So.
Sure. Let me go ahead and share my screen. All right.
Cool. So we have Emily's
And you all see my screen. Awesome. Okay. I'm going to start by just showing the original Swooter game. So I already have it kind of queued up here, ready to go. Whoops. So the name is dumb. I called it Swooter_py.py. It's a terrible name. We'll name this one something better. But if I pull it up, you can see this is the main game. It has the ability to join a guild, which does nothing. It just puts a cape on your character or not. And you can upgrade your sword if you get enough coins. And here we're just going to hit play game. So I can hit the W and S keys to make this move up and down. I collect the coins. I can hit the space bar to shoot the zombies with my sword. That's why it's called Swooter. If I collect enough coins and if I shoot enough zombies, you'll see that their shirts change color. And then they start, so right there, they change to purple. Now they take 2 shots per. But upgrading your sword will make them take less. So if I can at least stay alive enough to get 20 coins, and the animation or the look of the sword will change slightly too. So now they're black. Now they take 3. Now if they go off or if they hit me, I lose a life, right? So I got 22 coins. So now I can hit this button and I can upgrade my sword. Now my sword will do 2 damage basically per each time that I shoot it. If I hit join a guild, you'll see now my character's wearing a cape. And if you can kind of tell on the handle of the sword, there's a little bit more decoration. So, and you've got your health up here. You've got your number of coins, enemies eliminated, all that kind of fun stuff. So you can get your high score, that kind of stuff. We are going to be doing something a little bit less exciting than that. We're not going to have the menu and all of that. We're just going to create basically a coin collector. So I think it's this one. Oh. Which one is it? Give me an example. There we go. So we're basically going to be creating this. So we'll be able to move it up and down. We'll collect coins as we go. And you'll see the coin counter up at the top. This is what we're going to do in 45 minutes or so. So let's go ahead and get started. Let me set up my screen so I can see my reference code. There we go. All right. So we're just going to, I already named this one. It's just called Swooter_LT. That's going to be Scooter Light, basically, .py. And the first thing we're going to do, we're just going to bring in all of our imports, right? So I'm copying some of this from another screen, so I don't need to type all of this one out. We're going to use Pygame, right? This is the package we're using. Random is what we're going to use to try to randomize when things come out from the other side of the screen. It wouldn't be fun if they all came out in the same locations every time. We're just importing more things from Pygame. And from the sys package, we're importing exit. And that's what's going to allow us, whenever we hit the X game, or hit the X in the window, it's going to allow everything to like kind of close down completely, and we won't have any artifacts running in the background. All right, so now we will start the actual code for the game. And I'm just throwing in some pretty stuff so we can see it. So I use Atom for my coding. I like it. I've installed a bunch of different packages, I guess, to add on to Atom too, but sometimes it's annoying because it will, if I create a comment up here and I hit enter, it's going to bring that comment along. So kind of fun to play around with the Atom add-ons if anybody hasn't used Atom before. So first thing we're going to do is we're just going to set up our screen and our background. So I'm just going to say, all right, our width of our screen is going to be 640. And we'll say that our height is going to be 480. And we're just going to create a little run game equals true. So every time we start it, it's automatically going to set run game to true. If you remember, mine had a menu. Mine actually starts run game equals false. And then when you click the start button, it starts running the game itself, and that changes to true. So I already have backgrounds and things set up, so I will show you in my images. This is my game fill background, and I think I just made these in something super simple. This is the menu background, and you can see the different kinds of swords. So as you upgrade your sword, it looks really tiny. First one's just a little wooden sword. Then we get some excitement on the handle looking nicer, and then this is the final sword. So that's what upgrades. We've got our different zombies with their different colored shirts, all that fun stuff, and then the player with and without. So these I've already set up. If you wanted to create this game on your own, you would have to kind of create little images for yourself in the game. But let's go back. Okay. So the first thing we're going to do is we're going to fill in that background. So we're going to say background equals Pygame. Can I type? Maybe. Dot. I'm actually going to copy this one so that I get the right address. Pygame.image.load, and these are the actual. This comes from the actual Pygame package. So we're pulling these pieces out, and then this is the location of the actual image. Right? It's in this images folder. And then we're getting this game fill. And that's the same thing that we're showing here. Images folder, game fill. Then we're going to set up the actual screen. So screen equals, and again, we're going to use the Pygame package here. Display, set mode. And then this basically just takes a tuple, width for width, and height, which we set up above. And I don't know if you can hear my cat meowing in the background. So now we're going to say while run game. We're just going to create this big while loop. So while run game is true, you don't actually have to write out equals true. If you just say while run game, it's going to assume you mean true, which means this is just going to run over and over again because this is always going to be true. We're going to say for event in pygame.event.get. And this is one of the powerful pieces of Pygame. This pygame.event.get is what continues in the background within the Pygame package and actually says, okay, is there an event? Is there an event? Is there an event? And updates things as it goes through. And now we're just going to set up, the ability to quit the game. Basically, we're going to make sure that everything shuts down cleanly, that there's no artifacts running in the background, and we'll just say if event dot type equals pygame dot quit, and we exit. And you can see we imported exit up here. That's what shuts everything down. And then we're going to set up the screen to change over time. So we'll say screen.fill. And the first thing we're going to do is we're going to fill it with black. I could make this 0, 0, 0. It also reads 0 as just black. And what this does is it's going to erase the previous screen that we bring in. And then we will screen.blit. So a blit is basically copying and pasting pixels onto a screen, right? So we're first going to blit our background, which we set up there. And a tuple to set where we're going to set it. In this case, we're in the bottom right. Basically, if you set up an axis, we'd be in the bottom right. So we're looking at negatives and positives away from the screen. And then the last thing we're going to do is we're going to say pygame.display.flip. And this is what ultimately makes everything show up and moves us on to basically the next frame. So one thing to explain here is why we fill with black in between. You can imagine we've got this lit piece, and imagine that we're pasting our character onto the screen. And if we didn't have this here, if we just kept blitting the character, if we moved the character across, we basically see a tail from the character, right? It would copy paste, copy paste, copy paste, copy paste, and it would never disappear. We would see all of the different copy pastes. By adding this fill in here, this removes the old image, and then we add everything new. Hopefully that makes sense. And yeah, so we're going to save this, and then we're going to run it. And this is just going to give us our game screen. So this one is...
Emily, we have a couple of comments with questions coming in. Would you mind if we take that now?
Let me set this up. Let me run this really quickly, and then we will. Why did it? Oh, we missed an L here. Display. Isn't it like background is not defined? Oh, I missed a D. I can't type. Sorry, y'all. There we go. All right, this is it. We've got our first thing up here. No events are happening. It basically just gets to show this, but we've now got the background for our game. So let's take some questions. What's up?
Cool. So we have the first question from Jameson, and he asks, how did you create the images?
Honestly, I don't remember anymore what I used. You could just use Paint. They're really simple, especially since they're just kind of pixel images, because they're so small. Like you can see if I zoom in on these, you can see the individual pixels. So anything, just Paint or whatever. I do have the Adobe suite, so I can get creative and make all sorts of fun stuff in there. But these are super simple.
Cool. So we have another question from Himani, and she says, do you have your code on GitHub? Is this something they can find?
I don't remember if I put it on GitHub. I can check and I can make sure it's out there. I am MEK on GitHub, EMMIKAY. It might be. I can make sure to put it out there if it's not.
Awesome. Yeah, I think so. The other questions are just so which ID is better for coding? So Kiranjit asks if Visual Studio is better for coding, or what do you recommend?
I mean, I think that's also a personal preference sort of thing. I think Visual Studio is better if you want to set up. I think within that one, you can kind of create servers for yourself, so you can send things back and forth and kind of test how a website layout would look, pieces like that. I am partial to Atom. That's what I typically use. I know, I can't remember off the top of my head, but there's a different program that a lot of people I work with use. Personal preference, I'd say. Visual Studio is probably has more bells and whistles. I'd say that.
Okay, got it. Yeah, I think just one last question from Sneha. She says, can you explain blit and flip again?
So blit is a copy paste of pixels onto a screen, right? So the pixels that I have here, if we go to game fill, this is just a bunch of pixels. And blit says, all right, I'm going to copy those pixels onto the screen. And we're going to talk about something else in a little bit, which is it's called rect, and it's essentially short for rectangle. And that's what's going to create, okay, if these collide, something happens. Because if we just leave them as blits, it won't matter if they collide. They're just copy pasted onto a screen. Whenever we set up official like rectangles for them, now we're going to check, hey, if this rectangle hits this rectangle, then we're going to get a collision. Flip, because this is essentially an animation, at least the way that I think of this is, if you remember those little books whenever you were little that you can like thumb through and you can see the animation changing, we're flipping the page. We're flipping to the next page, and now we're running this all again. That's how I view it.
Got it. Yeah, I think that answers the next person's question as well, which is from Setu, and he says, can the image move or is it non-movable? So yeah, Setu, as Emily explained, you use the flip function, right?
Yep. Whenever we use a flip, that's what's going to create basically the next frame, and then the next frame is going to go through, and it's going to do something else. So it will move at the end.
Got it. Cool.
All right.
Yeah, I think that's all the questions we have. So yeah, you can go ahead, Emily.
Awesome. Let me get my code back. Okay. So the next thing we're going to do is we're actually going to add our player character to the screen. So it's going to be super simple. Right here, we're just going to create another variable that we call player, and it's going to be set up the same way. It's going to, as we did the background. We're going to be pygame.image.load. And I'm just going to go ahead and grab my code for the actual location. And now, super simple. We've already set up this blit for the background. We're just going to set up a blit for our character tip. Screen.blit. We called it player. We're going to drop it at 0, 100. That's just the oops. Why did I get another comma in there? And this is just the tuple basically that holds where we're going to put it. That's the X and Y coordinate. And that should add our player, assuming I copied and pasted and typed everything correctly. So let's see. Nope. No attribute lead. Where did I load? There we go. Look, there's our little character. We've now blitted our character onto the screen. I can't move him or anything yet. I have to still set up the actual events to do that. But now we've got our screen and we've got our first kind of item on the screen. All right, so from there, this is awesome, right? We can start with this, but this is all functional coding. And whenever we start adding lots and lots of things onto the screen, this is all going to get really complicated to follow, right? So while we just wrote this code, we're going to switch it up. We're going to go from functional to class-based. And it's going to make our life so much easier as we begin doing things and setting up our functions for making them move. So we'll just set up our classes. And the first class is just going to be called game. So we're going to say class game. And if you're not super comfortable in Python and you haven't done any object-oriented coding before, this first part's going to look a little bit weird. DEF is what we use to define a function. And then whenever we're initially setting up a class, we have to initialize it. So we're going to do define init with these double underscores before and after, and then self. And all this does is just say, hey, you're going to initialize yourself as basically a class or an object. And now we're going to set up all the different details about the self of the game. So I could set up something that's called class Emily, define init self, and I could say occupation analyst, or self.occupation equals analyst. I could say self.previous occupation equals biologist, right? And I could go through and pull out all these pieces of information about myself. That's what we're doing for each object in object-oriented coding. So I'll say self.runGame equals true, right? And now we've taken care of this piece of the code. So I can take this out of the bottom. And now we're going to set up self.width equals 640. And we're going to say self.height equals 480. And self.location equals 0, 0. And self.background equals, I'm just going to copy it from down here. This is what we're getting. And we'll say self.screen. So basically, I'm just assigning all of these to our game. So we will set up a game, and it's going to then create all of these different variables around the object game. I need screen, so it's going to be this one. Yeah, okay, awesome. So we've set up the game class. Now we're going to set up the player class. So class player. We're going to do the same thing. We're going to define and initialize self. And then we're going to set up our image. Let's copy it from down here. And we're going to just set up our x and y. I'm going to say self.x is going to be 25 is our x, and self.y is going to be 100. And then we're just going to set up a function for this object that just draws this object on the screen. So we're going to say define draw and self. It's going to run it on itself. And I need a colon. And we're going to say game.screen.blit. So we're actually using the game class up here. And because the game itself owns the screen. It gets a little bit confusing, but if you play around with it, you should start to understand. Game.screen, calling this game class up here, and then .blit, and we're going to say self.image. Oops. So now we're pulling this image, right? We have self.image, which is going to be our little image of the knight. And then we're going to have a tuple of the location. So we'll say self.x and self.y. So now you can imagine we can change this over time. So I can say, hey, if I press the W key, I want this to change by -5. So now we'll get closer to the top, that sort of thing. So hopefully that makes sense. And now we're just going to kind of write out what our main code will be. I'm just going to give us a little main code. And now we just have to set up our actual classes. So we'll say game equals game. And we'll say player equals player. And now we can use this same run game, but now we have to put game in front of it. While game.run game, right? Because run game now exists up here. So if we want to call it back, we have to tell it which self it is. And the self is game, which we just named right here. So while game.run game, we're still going to do a lot of these same things. We are going to game.screen.fill with 0, just like we did down here. I just added game in front of the word screen. We're going to do game.screen.blit, and we're going to do game.background, which is the same thing that we did down here. We just called it background. Now we're calling it background from within this object. And game.location, just telling you where to go. We're going to go ahead then and add our screen elements. And we'll say player.draw, which we basically, this screen.blit.player, we just built that in up here. So now it'll run this function without us having to write out all this code. It'll just do this piece. And then we can have the screen update. Pygame.display.blit, just like we had before. And then we'll have our event handler after that. And now we make sure that I typed everything correctly, and we should get the exact same thing that we had before. Isn't it like, oh, JK. Apparently I was telling a joke. Width is not defined. Width is, oh, I didn't write self, sorry. This is self width and self.height. Doesn't matter how much you code, you will always make little mistakes like that. But now you can see, now this is all object-oriented, and we still have our character on screen. This will make it a lot easier to keep track of where our character is on the screen. And then as we have a whole bunch of things like coins and stuff going across the screen, it's going to help us keep track of that.
Awesome. So we have a couple more. Yeah, yep. We have a couple more questions. And so we have one from Seto again, and he says, can we replace the images with 3D images? And I assume he means like a .3ds file or that sort.
If you want a game that moves around in 3D space, you'd have to dig into the Pygame documentation for that. I don't know that for sure. If it is just, I mean, if you draw something that looks like it's 3D, obviously you can place that in there. But I'm not sure about the 3D capabilities, especially since they've come out with Pygame 2 within the past few months. Definitely would be cool to dig in. I have not done that yet. So I'd encourage you to explore that for yourself and just look up Pygame in 3D and see what you find.
Awesome. Cool. So we have another question from Kyle. Did you read AI, and I'm sorry if I butchered this name, AI Swigard's Pygame books? Those are cool and free books. So is that something you've read, Emily? Is it something you recommend?
I have not. I dug around and just like looked for a bunch of Pygame tutorials and all sorts of things. Pygame itself actually has a lot of tutorials on their website for setting up games, and then to make it do kind of what I wanted it to do, I think I combined a whole lot of wisdom from a whole lot of other people. So, and that's what I would encourage anybody else to do too. There's lots of documentation out there, just like that book that they're talking about. and so many different tutorials. If you want your game to do something completely different than my game does, you can use kind of those first few pointers from this and then move on to what somebody else has done and create something completely different.
Mhm. Yeah, I mean, mix and match, make your own.
Yep.
It's all fun and games here. So, yeah. So we have another question from Prabhakar. He asks, which command prompt are you using?
From within. This one. I'm using git bash.
Yeah. Okay. Git
Because
bash.
I don't like using the actual Windows one. So that's
Yeah.
usually what I use.
Yeah. I feel like a lot of people, for some reason, don't like using the Windows one. So, yeah. And we can have one more question. A LinkedIn user asks us, what version of Python language is being used here?
I have the latest version installed, so whichever one is the latest. I don't remember off the top of my head. I don't know which version we're on, but I keep mine up to date.
Got it. So the latest version, cool. Yeah, so I think we can continue, Emily. So yeah.
Awesome. So the next thing that we're going to set up is we're actually going to allow the player to move. So we're going to create a velocity for our character. So basically, this is how many pixels per frame are we going to move. So we'll say self.vel for velocity, and it's going to be 7. And now we are going to set up, let's see, what do I want to do? Let's set up our keys first. So this is actually going to come down here. We've set up our player and we've set up our game. And now we're going to initialize our key states. So key state equals, and this is how I set it up. And this is kind of from my own head. I'm sure there's lots of other ways to do this. There's lots of ways to code lots of things, right? If you all come up with something better, go for it. What I did here is I just created basically an array, a list of 2 different key states. And the first one is the W key. And the second one is the S key. I probably could have set this up as a dictionary too, right? So that I could actually see W and S set up. This is how I initially did it. And these are going to set it up as up, down. And just in case anybody's like super new to Python, anytime I start anything with a hash sign, that actually creates a comment. So that means I typed main code here. This code won't run. It's just for notes. Same thing here. This is just for a note to myself. It will not run in the actual code. So basically we're starting out saying the W key is not pushed down and the S key is not pushed down. They're both set to false, or 0 or 1, or however you want to look at it. So now we have to actually handle the events. So we've already got our, okay, if event type is quit, this is what we do. Now we're going to have to check if our event type is key press. So I'm going to say if event.type. So Pygame has its own built-in types, so I can actually say Pygame.key down. So now we're saying, did I press a key down? And it's going to search for that. And I'm going to say if event.key equals, and this is also from Pygame, this is how they actually call out the different keys. It's K, capital K _ W. So now we're saying, all right, if the event was a key being pushed down, then we're going to check if the key that was pushed down was a W. And if it was, then we're going to say key state 0. Key state 0 equals true now instead of false. So one thing to note, if you haven't done a whole lot of Python, Python is 0 indexed, which means I'm pulling the index of this list up here, and this first one is going to be 0, and the second one is going to be 1. There are some other types of code that are 1 indexed, so it will go 1 and then 2. In this case, whenever I'm calling for this first one, I'm going to use 0 because we're 0 indexed. So key state 0 equals true. And now I'm going to say else if elif event.key equals K _ S, then we're going to say key state 1 is going to be true. So we're checking for the W and the S keys to be pushed down. Now, when I first did this, I was like, okay, great, perfect. This will be awesome. I'll just set this up. And I hit the button the first time and my character flew off the top of the screen because we also have to deal with key up. All this is telling it is, hey, the key was pushed down, so we'll leave this true. We also have to tell it to do something whenever we lift the key up, right? So now we're going to say if, actually we just make this elif. Elif event.type equals Pygame.key up. We're basically going to do the same thing except backwards. So I can just copy paste this. And now I can make this false instead. Maybe. Okay. Hopefully that makes sense for everybody. This is just looking whether keys are pressed or not pressed, basically. So we've set that up. Now we actually have to set something up for our player to move. So we're going to make another function here under this object, and we're going to say define move self. And we're going to say if key state 0. So remember, we don't have to write out equals true. If I just say if key state 0, it's checking if it's true. If it's false, it won't do this. We're going to check if. So we could just say we're going to subtract 7 from it, right? But we want to make sure that we're within the bounds of the top and bottom of the screen. If I just say subtract 7, we could go way, way, way off the screen, and that doesn't make any sense for us, right? So I need to kind of do a check first to make sure that this isn't going to go below 0. So I'll say if self.y minus self.velocity, right? Which we've got velocity up here. It's going to be 7 every time. We could change this if we wanted our character to be faster or slower. If self, what did I just do? I added a 0 in here. Sorry. So if self.y minus self.velocity is greater than or equal to 0, then we're just going to go ahead and say awesome. Self.y is going to now equal, well, actually, we're going to say minus equals. Minus equals means the same. I could say self.y equals self.y minus self.velocity. Minus equals allow us to skip part of that. I can just say self.y minus equals self.velocity. And this is just going to take its initial location and subtract 7 from it. And now it's at a new location on the screen. And we're going to say if, actually, I guess I can just use else. So else is going to be if it's less than 0. We're just going to set it to 0 because we don't actually want it to go off the screen, right? So we'll say self.y equals 0. And now we basically have to do the same thing for the bottom, except we're going to use slightly different numbers. This one's going to be key state 1 because now we're looking at S. And we're going to say if it is less than equal to 480 is our total height. So I'm going to do it as 430 so that we don't go off the screen. And then I'm going to say this one's going to be plus instead of minus. And this one's going to be plus equals. And otherwise, it's going to be set to 430. So this is telling it where it's going to be on the screen whenever we push those buttons. And now we just have to actually use our move. So we're gonna set up this function running here, player.move. All right, let's check it out. You've watched me code for long enough. Let's see how it goes. Let's see what I messed up this time. Okay, there we go. All right. We're not getting anything when I push the keys. So we messed something up. Find out what I messed up. KW. KS. False, false. This is right. Player.move. The good news is if it gets really weird, I can always just copy paste some code to make sure it works right.
Yeah.
So this all looks right. I don't need to start any more things here. Let's try it. I used equals everywhere, right? Sometimes I forget my double equal signs because I go back and forth between SQL and Python. Um, all right, let's.
So we have an insight from a
Yeah,
viewer.
go for it.
Shankara says player.move is outside the for loop. So is that maybe the issue?
Um, it is inside. It's inside the while, but it's outside the for loop. So yes, we do want it to be outside the for loop.
Got it.
But I am gonna go ahead and just copy this to make sure that I didn't. See if anything changes. Added an enter sign there. Let's do this. Just to make sure I didn't do anything weird. And we'll save. Oh, you know what? I bet I didn't save it. Right. So now we're going up and down really fast. That is because we did not set our frame rate on the computer. So I can't even stop it anywhere in the middle because I've got too many frames running in the background because my computer's too powerful for it. So one other thing that we need to set up is our actual in-game clock and our frames per second. So same thing, we're going to add now some more attributes to the game itself. And we'll say .clock equals pygame.time.clock. And then we're going to set up our actual frames per second. Self.fps is going to equal 60. So if you want to speed up or slow down the way that the character moves, you could change the frames per second if you wanted to also, or you could change the velocity down here. Up to you how you want to do it. And now we have to set up one more piece. We have to set up the clock at the end. So at the very end, we're going to say game.clock.tick and game.fps. So now I will remember to save it this time. And I left it open. And let's run it one more time. Great. Now I can move my character up and down. And I could change the speed if I wanted to move in faster or slower. Woo! Awesome. We've got our first moving piece of this. Now we need to start adding coins. Does anybody have any questions there?
Yeah. So we have a couple of questions, I think, about programming languages in general. So Kevin, for example, tuning in from YouTube, asks us, can you use Python with engines like Unity or Unreal?
Honestly, I don't know. Because most of my expertise comes in the data world, I'm less of an actual computer programmer. This was sort of a fun project that I did on the side, so I'm not a good one for that. I would say I kind of doubt it. Python is. Oh, there we go. Somebody else says we can, but I don't know that Python is typically the language that people use for gaming. Right. This is kind of a cool, different way to do it, but it's not the typical gaming language that somebody would use.
Got it. Yeah, I mean, talking about typical gaming languages, we got a question from Prabhakar who asks if you think C++ language is more preferred. Is that?
I mean, for sure. I'm sure that there's lots of different languages that are used in gaming. Python is definitely not the one to use if you want to like truly be a game developer. It's awesome if you're learning Python and you're using this to kind of skill yourself up. If you want to create you could create a full-blown game in this, but it's going to be a relatively basic full-blown game. If you want to go create the next Halo, you're going to need other languages.
That's insightful. I think, yeah, we have another comment from Vinay who adds on to the resources that were recommended by Kyle earlier. He says no starch press books are also awesome. So anyone here who wants to learn more about Pygame, more, further than what Emily is teaching us today, check out these books. I mean, our audience are recommending great stuff. So yeah, Kyle says this is a great brain workout. Thank you, Kyle, for staying, and we're happy that you're enjoying it. And yeah, let's just take one last question from Setu, who asks, any Python libraries version differentiation occurs when we execute? So
Uh,
yeah.
I mean, you should be fine with the libraries that I have here. They all work well with each other. Obviously, if you've done much in Python in the past, you'll know that packages can be a giant pain sometimes, because sometimes new versions don't work well with old versions of packages, which is why a lot of people use different environments within their desktop, basically. So something like Anaconda is great to use. You can download that, and then you can create separate environments. So if you know, hey, I know this package doesn't work with this iteration of Python, so I'm going to use this environment for this kind of coding and this environment for this kind of coding. I think everything here works pretty well with any of the packages that I have downloaded or have used, but always something that you have to keep in mind. Oh, somebody asked me what Python I'm using. It's Python 3.9.5 because it shows up every time
Ah,
right here.
awesome. Thank you so much for taking the questions, Emily.
Yeah.
And yeah, I think we can go ahead and get started on the coins. I'm
All
excited.
right. Let's add some coins to our screen. All right. So first thing we're gonna do, and this can be done lots and lots of different ways. I used big numbers just because it worked for myself. And I messed around with the numbers a bunch before I found like the speed that I wanted the coins to go across the screen. So I set this first coin timer up to equal 3,000. So it's a pretty big number. Got the number 3,000 here. Every time this goes down to 0, I think I have it put another coin out on the screen. So now we need to make a class for our coins. So I made the timer part of the game, and now we're going to make a separate class for our coins. So we'll say class coin, and we're going to set this up the same way that we did the other ones. Extra tab in there. We're going to initialize it. And self. And we're going to do the same thing about self.image. And I already have the image created for the coins. Copy paste so I don't mistype it. We got self.x equals 640. Self.y equals 100. So remember, these are moving left and right along the x-axis, whereas our character is moving along the y-axis. So the first coin that comes out is always going to start at the same spot. I didn't randomize that one, but then it'll change. Velocity equals 2. And self.coins. All right, so now this is how I handle the coins. Like I said, I'm sure there are lots of ways to do this. I basically created a list of lists. So it's arrays within arrays. That's going to take the self.x and self.y. So what we're going to do is every time we add a new coin, it's going to append it onto this list that we created here. So if I added a new coin and appended it, we'd be adding a new one that now says, imagine it being like self2.x and self2.y. Okay, so that's how we're going to handle this. It's going to start always with this first coin, and then we're going to create a function right here to add new coins to the list. So we define new self. So our function is just called new. We say self.y equals, and I'm going to set this to random. So this is choosing where along the y-axis we're going to drop it. And we're going to say random integer. And I want the integer to be between 50 and 430. And now I'm going to say self.coins.append, right? So we're appending another list or array within this list. And it's going to append self.x, self.y. So we want the x to stay the same because we always want it to come out at the edge of the screen over here. But we want the y to be different so that it's coming across at different locations. So it's always going to keep the same self.x, but now it's going to create a different self.y that's somewhere in between 50 and 430. All right, so now we need to set up our actual coin. So we'll say coin equals coin, and that initializes, right? It's running this first function up here, which initializes our first coin. Sorry, I use an MMO mouse, and so if you can see it, it has like numbers on the sides. Every once in a while, my thumb bumps one, and I get an extra number on the screen. So then we're going to actually set up our coin timer in here. So within this while loop, we're going to, I'll just actually write this out here. We'll say set coin timer. And we're going to say game.cointimer minus equals random.randint 0,100. So what this is saying is, all right, we're going to pull a random integer between 0 and 100. So it could pull 55 or something like that, right? And that's going to be subtracted each time we go through a frame. That's going to be subtracted from the number 3000. And that's saying when a coin is going to be created. Once that goes down to 0, we're going to create a new coin. And we're going to deal with that down here. So after layer.draw, we're going to do it here. We're going to say coins. And we're going to say, all right, if game.cointimer is less than or equal to 0, then we're going to do coin.new, which is the function that we just made, and it's going to add a coin to our array. And we're going to say game.cointimer equals 5000. So I started it at 3000 because I want it to come out right away, but then there'll be a little bit more of a break afterwards. Mm-hmm. And now we have to handle each coin individually. So we're going to say for C in coin.coins, and coins is the name of the array, right? So we're just going to go through each item that ends up in this array. We're basically going to make that show up on the screen. So we're going to say, let's just scroll down. We're going to say go through the, so it's going to grab the first item in there, which is going to be our x-axis, right? So now we're saying for C, so if C is 1, this is the first, C is 0, this is the first one. So we're going to take the first item in here, actually up here, sorry. So we're taking that x, and we're going to say C0 minus equals coin.velocity. So now we're going to subtract our velocity of 2 from it, because that's what we set our velocity. And this is going to create basically our new location on the screen for that coin. Mm-hmm. And now we just have to make it show up. We'll say game.screen.blit coin.image and C, because this is going through and getting our X and Y coordinates for each one. Mm-hmm. Hopefully that makes a decent amount of sense. And now let's see if it works, or if I forgot to add anything to it. All right, look, we've got coins here. So they're starting in the wrong location, but you can see more and more are showing up. So we got somewhere. Now we figure out why they're showing up over there. What did I do wrong? Because that's a little weird. They should be showing up on the other side of the screen and going across it. Velocity, image.
Oh, we have an insight from Debbie who says you put equal to minus, not minus equal to. Maybe that's...
Thank you.
Thank you, Debbie.
Yep, that does it. Perfect. So what you can see, the coins are just going to go through me. Nothing's going to happen. Because if you remember, we talked about blitz versus rects. This is where that's going to come into play. We need to start handling these collisions so that something actually happens in the game. So let's handle the collisions. So we need to create rects for everything. So let's go ahead and create a rect for our character. So right here under our move piece, we're going to define player rect. and we'll say player rect equals pygame.rect player.image.getRect. So this is basically pulling, right? We have the player above. It's going to grab the image from the player class, and it's going to get the rectangle that goes around it, basically. So it doesn't really matter what shape your pixels are. It's going to grab a rectangle around it. And then we're going to set where that is in relation to the image. So we're going to say player rect.left equals player.x. And so basically we're saying, okay, we want the left side of the image to line up with basically where the player is. And then we'll say player rect.top is going to equal player.y. So this is going to create a rectangle that always sits on top of where the player is. And I could honestly be writing self on these rather than player. It's going to work either way. And then I'm going to go ahead and return player rect. So now there are these, imagine we're basically creating little invisible rectangles around the blit or the pixels that we pasted onto the screen. Now we need to handle that within the coins themselves. They all need their own little rects as well. So let's go ahead and say for C in coins, we're going to say coin rect equals pygame.rect and coin.image.getRect. It's my favorite thing, I'm not going to lie. Coin rect.left, and this is just setting it up so that there's always a rectangle above each of the coins. We'll see 0. Right, so we're getting our x-axis location. And coin rect.top is going to take the y-axis location, so C1. This is doing this for every coin. So this will create, for as many coins as we have on the screen, there will be little invisible rectangles on top of them. And now we have to say, we have to handle two different things, right? We have to handle if the coin goes off the screen, and we need to handle if our player hits the coin. The reason why we have to include the player going off the screen, or the coin going off the screen, is because ultimately, we want to keep these arrays as small as possible. It doesn't really matter for a game like this. Like you'd have to let the game sit there for a really, really long time before you ended up with something that your memory couldn't handle. But when you think about other games and other development, you don't want to this would essentially create a memory leak, right? Every time a coin would go off the screen, it would still be recording and still be going to the left and left and left. But we actually want that to fall out of our array so that we're not holding all of that information in memory. So we're going to set up the first thing. We're going to say if coin rect.left is less than or equal to 0, which means this went off the screen. Then we're going to go ahead and pop that coin out of the list. So I'll say coin.coins.pop. This is just going to remove it. Coin.coins.index C, because that's C is the coin that we're on. So that'll remove that coin from the list so we don't end up with a memory leak. And we'll also say if coin rect dot. So now there's a new function we're going to use called collide rect. And this is from within Pygame. So we're going to say collide rect player dot player rect. So now we're saying, hey, if this coin rectangle collides with this player rectangle, then what do we do? And that means we're just going to pop that coin out of the list. Coins.index. Okay. And that's it. Now, whenever we run into a coin, assuming I didn't mess something else up, we should see it disappear. So I can move up and down. Now, if this coin hits me, it disappears. Yes. That one will fall off. So that's awesome. Everything's working as we hoped it would. And now the last thing that we really need in our little game is we need to be able to see our score. So one last thing that we're going to do up here, we're going to add a coin counter. So we'll say self.coins, and that's going to equal 0. And we're going to create this font. We're going to say small font equals pygame.font. And this is just the actual like Pygame package methods and functions. And we're just going to use none. It'll use the default font and size 24. And now I'm going to create another function for game, and I'm going to call it show text. Now, I'm going to use the same function that I used for my game. I allowed myself, I created basically a function that would take a bunch of different variables, so I could just show text without a variable in it, or I could show text with variables if I wanted them to change over time. So I created something that takes the self, which is the game, it takes the message that you type in, the X and Y location of where you want those messages, and then a variable if you want it. It's going to default to none, so that I could just, if I just wanted to put Swooter up in the corner, I could do that where by just typing in the message and where I wanted it to be located. Or if I want a variable in it, this is now optional. It will default to none, but I can add one if I want to. And in this case, we are going to use it. So I'm going to say if variable is not equal to none. So if I actually put a variable in here, then we're going to go ahead and say text equals self.smallfont.render. Render is what Pygame is going to use to make it show up on the screen. Message, which is what we type, plus we're going to turn our variable into a string. And then this is part of render. We're going to say we want it to show up true, and then the color that we want it to be. So we're going to make it just white. Okay. So that should handle that one. And now we're going to say else if there is no variable, then text is just going to equal self.smallfont.render. And it's basically just going to write out your message. So your message, and then true, it is going to be visible, and then 255 to make it white. Which we're not actually using this. We're just gonna use this top one. But for anybody else who wants to kind of mess around with this and create something, this is just a nice way to make a reusable function. So any text you want to put on the screen has kind of an easy way to do it. Then we'll make our text rect. It's going to be text.getRect. And where we're going to put it, text rect.topRight is going to be at our X and Y location. And then we're going to blit it onto the screen. So self.screen.blit text rect. Okay. That should work. Now we have to actually add that to our code. So one thing that we need to add in here, because we started using some of these Pygame fonts, for some reason, this is the point where we have to actually start with pygame.init. So I'm just going to add that up here, pygame.init. Otherwise, our fonts won't load it. So we're initializing Pygame. And now we're going to set up the actual coins number. So where do we do the collide? All right, so right here, this is where we handle collisions. We also now, whenever we collide with it, we want to add to our coins. So plus equals 1. Now, every time we hit a coin, we're going to add 1 coin to our count that we created in the game. And then we need to actually show our score. So we can do that here. We can say game.showText. And this is the function that we just created. So the first part is my message. I'm going to make my message coins with a space. And now my variable is, or actually my location, sorry. I want it to be at 350 and 15. So that's my X and Y. And now the variable that I want to put it is game.coins. And so that's going to start out as an integer, right? But because my function up here turns it into a string, that'll allow it to actually print out and show our text of how many coins we have. So let's save this one more time. And we should now have a working game. Oh, what doesn't like? Line 28. What did I mistype? I did it again.
Wow.
Added another minus in there that didn't even belong there. Let's try again. All right, now we got coin 0 up at the top. Let's make sure the code works. There we go. Now you can see that number is going to go up. Now, I think you could hopefully see how you could add lives or something else into this. You could create another thing up here that says lives and start it with the number 3. And anytime a coin goes off the screen, you're going to subtract 1 from the life, and that's how your game could actually end. But now we've got this is one of those infinity games, right, where you can just keep going. You can never die in this. But yeah,
I do.
congratulations! You all now know how to make a game.
Also, I mean, yeah, I think the best part of this is that it's an infinity game. You can't lose. So I feel like if I had Swooter, I'd be playing this for hours. So yeah, thank you so much, Emily. We had a few questions come in towards the end. So
Yeah.
I think, yeah, one of them is about like the code itself. So I think let's take that first. So Ruben from YouTube asks, is it safe to pop a coin out of the array while still looping over that array?
Yes, because we're actually popping out that specific index.
Okay, got it. Yeah, I think that's all the questions we had on the code. Kevin asks, he mentions that it's kind of off
Oh,
topic,
do
but
I
do you
have?
have a favorite game? Yeah.
Yeah. So I play Final Fantasy 14. So if anybody else is on Diablo's server on Final Fantasy 14, that's what I play. I've been playing the remake of Final Fantasy 7 recently. I managed to get my hands on like all of the consoles. So I was playing like Assassin's Creed Valhalla on the Xbox X and Final Fantasy on the PS5, and I don't know. I've played Pokemon and Breath of the Wind and everything on the Switch. So if anybody's trying to get their hands on it, it's Stock Drops is the Discord. That's how I managed to like snag all of the different consoles. But yeah, I play a lot of different games. I typically like RPGs.
Nice. I think, oh, RPGs. Have you tried out Genshin Impact? That's a game I'm
I
obsessed with
have.
right
I
now.
played that one on my phone actually. Is the only place that I've
Same.
played that one. So yeah.
Yeah. I think it's pretty similar to Zelda. So yeah,
Mm-hmm.
fun games. Yeah.
Yeah.
Cool. And we're getting a lot of compliments, Emily. So Kyle says, nice code. It's impressive. And Emerson asks, what's the
Let
GitHub
me
repo name again?
let me check my GitHub. I can't remember if I put that up or not. So let's look.
Yeah. So GitHub. Okay, we have Sanskar in the background who's done it for us. So it's github.com/emmik. That's EMMIKAY.
K-A-Y. Yep. MEK.
Yeah, cool. So yeah, anyone who wants to check out Emily's GitHub or this code, just check it out here. So Sanskar has put up a banner for us. Thank you, Sanskar. So yeah, thank you everyone for tuning in today. We hope that you found this tutorial helpful. Thank you if you stuck with us till the very end and interacted with us with doubts. Yeah, we now hope that you walked away with enough information to make your own Swooter. Thank you, Emily, for being such an awesome guest, and we're so happy to have you as an all-star. And yeah, we can't wait to do more events like this in the future.
Awesome. Thanks everybody for tuning in, and thanks for hosting
Thank
me.
you. Thank you. Awesome. See you, everyone. I'll play the intro now. So thank you again for tuning in, and bye bye.